off the boat, say something, okay, so we can pick you back up. So today we're going to address horizontal and oblique asymptotes. Yesterday we did vertical asymptotes, x-intercepts, stuff like that, right? Today we're going to do horizontal and oblique. Horizontal, like the horizon, flat, okay? That's a flat wall. Oblique is not a word we use every day, right? In some textbooks, some classes, we use the word slant, which I like better too. Slant makes more sense to me. Diagonal would be another word there, or even in common everyday we would say sideways, right? It's just the line that's sideways, diagonal. Okay, so we're gonna find the flat asymptotes and the oblique asymptotes. Okay, guys. All right, so let's begin. So let's do part one. Before we start doing those, we need to refresh our memory and be very clear about what a degree is. Okay, we've looked at degrees in the past, but this has to be super clear to us. Okay, so I'm going to give you two scenarios of two functions. Okay, a rational function, such as these. By the way, these are the ones that we're currently working on. Those are the ones that we'll continue to work on. Okay, on the last unit, we also worked on these polynomials, as you recall. But the way you calculate the degree is very different. Okay, so this one is called factored form of a polynomial. Okay, and this one over here, we call it a standard form. Okay. And obviously, the first visual difference that you would see is the parentheses, right? One has the parentheses, the other ones do not have parentheses. Okay, so that would be an easy way to know the difference. But the way we calculate the degree is significantly different. So as you recall, on factored form, to get the degree, we add the exponents, the powers. Okay, right? Now, back when we had that test for factored form, we would miss this question a lot. A lot of you would, because we would forget one of these exponents, right? When I don't have an exponent, such as this case, what is the exponent? 1, right? So don't forget to put that 1. Okay, so 1, 2, 3. So that tells us this is a 6th degree polynomial, even function, positive function, right? A lot of information there for us. Equals the highest one. Yeah, so that's this one. You're good, very good. Hey, Carlos, we just started the notes, okay? Okay, so on this kind, on standard form, to calculate the degree, we say we take the highest power. Now, one confusing part is you might think the highest power of the whole fraction. That's not the case. We look at the numerator and the denominator independently. So we think of the top by itself and the bottom by itself. Okay, so the degree of the top would be a 2. Okay, so this is the degree 2 function. The top, the numerator. Okay, but the denominator, the bottom, what's the power of the bottom one, guys? 1, right? Again, if the power's not there, it's really a 1. Okay, so this is a 1. So it's weird because you would think the whole fraction would have a degree, but that's not how we talk about it. We say the top has a degree and the bottom has a degree. Is that clear, guys? Does there anybody have a question about that? Okay, because that has to be super clear before we can do the next part. Okay, and I'll tell you today and this week and next week, we're going to focus on that form. Okay, we're going to focus on standard form. Okay. Okay, so let's move on to part 2. So that's kind of old information. Here's where we begin the new information.